Well, I grew up in Western Pennsylvania, and when I was a kid, the big rivers, the small streams, they were all dead thanks to acid mine drainage. My dream was always to take rivers like the Allegheny, the Monongahela, the Ohio, and all the other big streams and actually turn them into fisheries. This is going back to when I was 11 years old. And so when I came to work at West Virginia University, it was the perfect opportunity to actually clean up these streams, clean up the environment from all these old legacy mines.
We're here at the TNT site in West Virginia where we process acid mine drainage. It's one of hundreds of plants around West Virginia where we're actually cleaning the water and we're putting it back in the river, restoring aquatic life.
Hey, how are you guys doing?
Good. Hey, Mark. How are you?
Mark Dickey
Jim,
with the DP.
how are you doing?
Hey, good to see you again.
Good to see you, Paul.
Hey, could you give us a tour of the plant?
Sure, yeah.
In the state of West Virginia, it's a very big problem.
This is our 100-ton hydrated lime silo.
Currently, with the transition away from coal, the mines are shutting down. And as these mines shut down, they leave behind open pits in the mines and they fill with water.
The lime slurry pumps through these and goes to the chemical injection manhole where it's injected into the AMD.
It's like filling up a glass as the water, either through groundwater or direct infiltration, will fill the glass up and eventually it spills over. And that's where we see potential acid mine drainage.
This is our 80-foot clarifier, and the center well is called the flocculator. In this flocculator, kind of all these small particles are bumping into each other, and it creates a heavier particle, and that particle settles down to the bottom.
And if you do have old legacy sites that generate acid mine drainage, how do you treat them most efficiently? How do you clean up ultimately watershed scale projects, which we've been pretty successful at? When the idea for collecting rare earths from that stream came along, I thought this is a nice way to add a revenue stream and help pay for that process. In 2015, the Department of Energy specified a desire to identify sources of critical minerals and rare earth elements that were available as byproducts of the energy industry, particularly coal. I talked to some friends in the industry, I accessed some old data sets, and it turns out there were a lot of rare earths in acid mine drainage that no one had ever looked at before.
We make a rare earth sludge, and then we take that through a process called acid leaching, where we turn it into a aqueous liquor solution that is concentrated in these rare earths. And what we will then do is extract that solution in a process called solvent extraction to concentrate those metals further into a solution where we can precipitate them and make a product.
We needed someone who was really good at automation, processing, sensors and controls, so we could automate this whole process and then take it that much closer to commercialization.
Rockwell Automation is a dominant player in the automation field. We're a system integrator for Rockwell Automation, so that's what we brought to bear when we implemented the PLC systems and the HMI system and SCADA systems for these new plants.
This is our control room. This is the MCC here to my left, and to my right is our large screen, the SCADA system.
Their main concern was in the pH control. pH is not linear. You can't just feed pH to a certain set point and have it do its magic.
Our entry point with the lime slurry on Glade Run is at 10.6.
So we decided that we're going to utilize all the equipment that Rockwell has, especially after we'd learned how well they integrate together.
That water mixes with the water from TNT and then Muddy Creek north of that, and that's what creates the good pH.
The Rockwell automation will allow us to do a couple different processes. It will help us recover the rare earth material that is in the raw water. Also, it will allow us to automate the actual recovery of the rare earth into a more purified form.
It takes time to leach these materials and to make adjustments. And now, with Rockwell, I can do 3 experiments in a day and not have to be watching them because the probes and the automation equipment do it for us.
Here, we can actually control everything at this plant, and we also have the capability to control all of these sites here listed on the screen.
As we went forward with them, we started showing the technology and the capabilities that they could have.
Control what the clarifiers do, control what the pumps do.
And once we showed them, you know, you can use your iPhone or your iPad from home to run the plant and understand what's going on, it really took off.
You don't have to have somebody there at the facility 24/7. We set the system up to where if the system faults, then you get an email and you can bring it up on your iPad or your iPhone and look at what the alarms is, and they can make adjustments in real time.
So this is our sludge pumping building. So right now we're pumping sludge that's pulling sludge from the clarifier. We're pumping it up into the mine. All of these motors on the pumps are controlled through the VFDs and the MCC in the control room.
Going from a bright idea to actual implementation involves a lot of steps, a lot of technology, a lot of specialized skills. We don't have those specialized skills here at the university. Rockwell does.
So let's go over, we have our NPDES discharge permit over here where it drops into Muddy Creek. We'll go over and look and see where we're putting the clean water back to the stream. This is all the hard work. This is what it's all about right here.
By cleaning the streams up, the stream's alive again.
This is the section of Muddy Creek that was previously dead. It had no aquatic life, no fish in it, and just this past year we had some brown trout in there.
It's a big deal for the state of West Virginia and any mining state.
We want to have a pristine environment, and with the process of the acid mine drainage remediation, we're taking a bad thing and turning it into something that is good for the environment.
We need partners like Rockwell in order to implement the technology in the field and make it a commercial reality.
It's just great to see that the DEP in West Virginia is really caring about the environment, and we're happy that Rockwell Automation can be a part of that.
Well, we're happy for you to be a part of it. Couldn't do without it.